thank you very much for coming to talk to my talk. So I'm Gilbert, and so I'm a CTO of CTOR Lab and also a member of Project Penguin engineering team and Zombie Club. Yeah, my talk is about building gas efficient smart contracts. And so just to start with, I just give everyone a quick overview of what is gas and why we care about that. Yeah, so gas is basically when every time you send a transaction on the Ethereum blockchain or any EVM chain, when you're doing the transaction, there are certain actions, and each different actions come with a different cost, and that's basically the fee you pay for the miner. And so among all these actions, there are two actions that are the most expensive ones, and they are just read and store the data to the blockchain storage. And so I just want to give everyone some quick small tips that even you are not a developer but you are working with the tech team, then you can probably just use these tips to just reduce the gas cost for your smart contracts. And so I would say the first one is if you can try to bundle multiple transactions into one. And the reason is because every transaction comes with a base cost. Even you do nothing, just by doing nothing, you still have a base cost. So let's say if you combine multiple transactions and you can save this gas, and that's why NFT aggregators and are and useful tools for saving gas on buying and or selling the NFTs. And the second one is, what I said, read and write data to a storage are the most expensive one. So it would be good if when you're designing your smart contract and just try to minimize the data you need to write on the chain or just try to compress it. And the third one is taking advantage of gas refund. So it's a very interesting property of the Ethereum blockchain is when you remove data from the blockchain, it actually give you some refund. And so if you're designing a contract and then or design your NFT, and if you whenever you get a chance to release the data, do it, and that will save your users quite a few gas fees. And the fourth thing is you can, if you are you need to use some data, try to, if it's fixed, use it as a constant, or cold data, basically you pass them into the contract when you're calling it. And so when you're talking about the gas efficient smart contract, we should definitely talk about the ERC-721A. And so ERC-721A developed by Azuki is one of the first contract that allows people to mint multiple tokens by paying the gas fee essentially as one token. And what they do is they're using the implicit ownership. They say when you mint 3 tokens, it only writes the information of the ownership to the first token, and not the rest of the tokens. And so it comes with, it's good for minting, but it also comes with some disadvantage especially in transfer and burning. And that's why in CTOR Lab we developed a new token called ERC-1155 Delta. And so unlike other ERC-1155 token, it is actually more like ERC-71. Each single token is unique. And it saves a lot of gas, and I'll talk a little bit more in the next slide. So ERC-71 is good for minting, but it scales poorly in transfer and especially the burning. But ERC-1155 token is the only token, and we can solve this trilemma. It's use a same amount of gas for minting multiple tokens, and the gas transfer is fixed. And also, when you're burning the token, you also get gas refund. And so for more details, you can just Google it, and you can see our website, and it has a more detailed benchmark. And next thing is a trick, some interesting techniques we can do with for saving gas fee. And this is so when you are designing your NFT contracts, you can actually leverage the token ID. So the token ID doesn't have to be starting with 1. It's like a 1, 2, 3, 4. It can be anything. So by doing that, you can actually encode some information into that. So at Project Penguin, we we're building like some soulbound systems and actually leverage these properties. So yeah, so we basically kind of encode the owner of the address to the token ID. So by doing this, we don't need to save these mappings on chance, and then they will guarantee like each users can get only one soulbound token. And this is a joint work between me and Davey and Lorenzo from the Project Penguin engineering team. Yeah, the next thing is the this is a thing we developed as CTOR Lab, and it is also a good example of how we can save a user's gas fee. So this project is called Linkforge. It's a pretty new technique we just recently released, and it's not yet on our website yet. But the idea is it is like a protocol that allows users to distribute NFTs through a unique secret link. So let's say you can scan a QR code or tag an RF tag, and then you can get a link and open it, and then you will get an NFT. But what that is different from other existing solution is this protocol is completely decentralized. It doesn't require any a centralized server for verifying the link. And so this makes it has a better security, and also the way we design it is extremely gas efficient. And so so this is I probably don't have time to go into the details of this, how it works. But basically, what it does is you only have you commit something on chain, and just by using a gasless signature to sign your link, some secrets inside your link. It just have a cryptographic signature on that, and use that. You can generate multiple links gasless, and you don't need to pay anything until a user claim their NFT. And so basically, this is how it works. And so I guess the lesson you can learn from here is if you can use a gasless signature, use it. It can just not only help you but also help your user to save the gas fee. Yeah, I guess that's end of my talk. And so Harry is our CEO at CTOR Lab. He has an amazing talk on talking about a 3D composable NFT, and it happened on Wednesday. So, but I think there will be a video, and so just feel free to check it out. And yeah, if there's any question, yeah, feel free to message me. And thank you very much for coming to my talk. Thank you.